Visit parthikachana.com for technology resources and stock analysis. 50 intermediate-level Hadoop interview questions along with their detailed answers. 1. What is Hadoop, and what are its core components? Answer. Hadoop is an open-source framework that allows for the distributed storage and processing of large datasets across clusters of computers using simple programming models. Its core components include HDFS, Hadoop Distributed File System, a distributed file system that stores data across various machines. YRN, yet another resource negotiator, a resource management layer responsible for job scheduling and cluster resource management. MapReduce, a programming model for processing large datasets in parallel by dividing the work into small chunks. 2. Explain the purpose of HDFS and how it ensures fault tolerance. Answer. HDFS, Hadoop Distributed File System, is designed to store vast amounts of data across multiple machines. It ensures fault tolerance through data replication, where each file is broken into blocks and replicated across multiple nodes in the cluster. If a node fails, the system can retrieve the data from another node where the replica is stored, thus ensuring data availability. 3. What is YRN, and how does it differ from the previous versions of Hadoop? Answer. YARN stands for Yet Another Resource Negotiator. It is responsible for managing resources in a Hadoop cluster and scheduling tasks. The key difference from earlier versions of Hadoop is that YRN decouples resource management from application processing, allowing multiple applications to run on the same Hadoop cluster. It provides more flexibility and scalability compared to the previous MapReduce-centric architecture. 4. How does the MapReduce framework work in Hadoop? Answer. MapReduce is a programming model used in Hadoop for processing large datasets. It works in 2 stages. Nap phase. Data is split into smaller chunks and the mapper processes each chunk, generating key-value pairs. Reduce phase. The reducer processes these key-value pairs, aggregates or filters them, and produces the final output. The framework automatically handles data distribution, parallelization, and fault tolerance. 5. What is a name node, and what role does it play in Hadoop? Answer. The name node is a master server in HDFS that manages the file system namespace and regulates access to files. It maintains metadata, such as the directory structure, file names, and block locations. The name node does not store actual data. It only manages the data stored across various data nodes. It is essential for managing the distributed storage across the cluster. 6. What is the difference between name node and data node? Answer. Name node manages metadata and controls access to data, such as keeping track of which blocks belong to which files. Data node stores actual data in the form of blocks and is responsible for reading and writing operations on the data as requested by clients or the name node. 7. What happens if the name node fails in Hadoop? Answer. In a traditional setup, a single name node failure would bring down the whole Hadoop cluster because the metadata is lost. To prevent this, Hadoop introduced a secondary name node for periodic backups, and more recently, Hadoop HA, high availability, configurations allow for the use of multiple active and standby name nodes with failover mechanisms. 8. Can you explain the concept of a secondary name node? Answer. The secondary name node is a helper node that periodically takes snapshots of the metadata stored in the name node, i.e., the file system's namespace, and merges the namespace image with the edit logs to prevent them from growing too large. Contrary to common belief, it is not a failover mechanism for the name node, but it helps in recovering the state if the name node crashes. 9. What are the main differences between Hadoop 1.x and Hadoop 2.x? Answer. Key differences include YRN. Hadoop 2.x introduced YRN, decoupling resource management from application management. Scalability. Hadoop 2.x can scale much higher due to YRN, allowing multiple applications to run simultaneously. HDFS Federation. Hadoop 2.x allows for horizontal scaling by introducing multiple namespaces in HDFS. High availability. Hadoop 2.x supports high availability, HA, for name nodes, reducing single points of failure. 10. What are the different modes in which Hadoop can run? Answer. Hadoop can run in 3 modes. Standalone mode, default mode, used for debugging and does not use HDFS or MapReduce. Pseudo-distributed mode, simulates a cluster on a single machine where HDFS and MapReduce are configured. Fully distributed mode, Hadoop is fully deployed across multiple machines in a real cluster. 11. What is the purpose of a combiner in MapReduce? Answer. A combiner acts as a mini reducer that runs after the mapper phase and before the data is sent to the reducer. It aggregates the intermediate map outputs to reduce the amount of data transferred over the network, thereby improving efficiency. The combiner's output is not guaranteed to be final and may be subject to further reduction. 12. What is the difference between a combiner and a reducer? Answer. Combiner, an optional step that helps optimize the data transfer between the mapper and the reducer by reducing the amount of intermediate data. Reducer, the mandatory final step that processes and aggregates the data coming from the mapper and possibly the combiner, and outputs the final result. 13. How does Hadoop ensure data integrity in HDFS? Answer. HDFS ensures data integrity by using checksums. When a file is written to HDFS, a checksum is computed for every block. During read operations, Hadoop verifies that the block data matches the stored checksum, ensuring that the data has not been corrupted. If the data is corrupted, HDFS fetches a replica of the block from another node. 14. What is data locality in Hadoop and why is it important? Answer. Data locality refers to the concept of moving computation closer to the data rather than moving data across the network. In Hadoop, the job scheduler ensures that MapReduce tasks are executed on the same nodes where the data resides, reducing network congestion and improving performance. This is crucial because moving large datasets over a network is costly and inefficient. 15. How does Hadoop achieve fault tolerance during data processing? Answer. Hadoop achieves fault tolerance through replication. HDFS stores multiple copies of data blocks on different nodes. Task re-execution. If a task fails, Hadoop automatically reschedules and re-executes it on another node using replicated data. Heartbeat mechanism. Hadoop continuously monitors nodes with heartbeats, and if a node fails, it reallocates the tasks to other available nodes. 16. What is speculative execution in Hadoop? Answer. Speculative execution is a performance optimization technique in Hadoop where slow-running tasks, or stragglers, are duplicated and executed in parallel on other nodes. The system completes the task using whichever node finishes first. This helps mitigate the effect of slow-running tasks and improves overall job performance. 17. What are some use cases where Hadoop is not suitable? Answer. Hadoop is not suitable for low latency processing. Hadoop is batch-oriented and not ideal for real-time applications. Small data processing. Hadoop's overhead makes it inefficient for small datasets. Graph-based data models. Hadoop's linear, batch processing model doesn't work well for iterative algorithms required in graph-based computations. 18. What are the limitations of Hadoop, and how do you address them? Answer. Some limitations of Hadoop include high latency. It's not designed for real-time data processing. Small file handling. Hadoop performs poorly with many small files due to its large block size. Complexity. Setting up, configuring, and managing Hadoop clusters can be challenging. These limitations can be addressed by using tools like Apache Spark for real-time processing, HDFS Federation for better namespace management, and integrating Hadoop with other technologies to enhance capabilities. 19. What is the function of job tracker and task tracker in Hadoop? Answer. In Hadoop 1.x, the job tracker is responsible for managing job submissions, tracking tasks, and resource management in the cluster. It splits jobs into tasks and assigns them to task trackers, which execute these tasks on individual nodes. In Hadoop 2.x, Job Tracker and Task Tracker have been replaced by Yarn's Resource Manager and Node Manager for better scalability. 20. What are HDFS block size and replication factor? Answer. HDFS block size, the unit of data storage in HDFS, typically 128 megabytes or 64 megabytes by default. Files are split into blocks of this size. Replication factor: the number of copies of each block stored in the cluster. The default replication factor is 3, meaning each block is replicated on 3 different nodes for fault tolerance. 21. What is the role of the resource manager in YARN? Answer: the resource manager is the central authority that allocates resources to various applications running on the Hadoop cluster. It tracks the available resources and assigns them to applications based on requirements. It works in conjunction with node managers running on individual nodes, which manage the local resources on each node. 22. What is the purpose of the node manager in YARN? Answer: the node manager is responsible for managing resources like CPU and memory on each node in the cluster. It monitors the health of its node, reports resources to the resource manager, and manages the execution of containers, units of task execution. Each node manager ensures that tasks running on its node stay within the allocated resource limits. 23. Explain the concept of a container in YARN. Answer: a container is a unit of resource allocation in YARN. It encapsulates a fixed amount of resources, CPU and memory, and is where application tasks execute. Containers are managed by node managers, and the resource manager assigns containers to various applications based on their resource needs. 24. What is a DAG, and how does it relate to Hadoop? Answer: a DAG, directed acyclic graph, is a graph with directed edges and no cycles. In the context of Hadoop, DAGs are often used in frameworks like Apache Tez to model complex workflows. Each node represents a task, and edges represent dependencies between tasks. DAG-based models provide more flexibility than the traditional MapReduce paradigm by allowing tasks to be represented as a sequence of operations with dependencies. 25. What is the difference between Apache Tez and MapReduce? Answer: Apache Tez is an advanced data processing framework built on Hadoop YARN. It improves upon the MapReduce model by allowing a more flexible DAG-based execution plan, which can handle complex workflows and reduce latency. While MapReduce follows a rigid 2-phase processing model, map and reduce, Tez enables multiple processing stages, optimizing the data flow and reducing the need for intermediate writes to disk. 26. What are the primary use cases for Hadoop YARN? Answer: Hadoop YARN is used in batch processing for large-scale data analytics and processing, interactive data processing, using tools like Apache Hive and Pig, stream processing, with tools like Apache Storm or Apache Flink, machine learning, using libraries like Mahout or mlib on Hadoop clusters. 27. What is Hadoop streaming and how can it be used? Answer: Hadoop streaming is a utility that allows users to create and run MapReduce jobs with any executable or script as the mapper or reducer. It enables the use of non-Java languages like Python, Ruby, or Perl for MapReduce tasks. Users can specify the script or program in the job configuration, and Hadoop handles the execution. 28. What are some common challenges when working with HDFS? Answer: common challenges include handling small files. HDFS is optimized for large files, and many small files can overwhelm the name node's memory. Data corruption. Although rare, hardware failures can lead to data corruption, which HDFS handles with replication. Node failure recovery. When nodes fail, HDFS needs to re-replicate blocks to maintain the replication factor, which can add to network traffic. 29. What is a rack awareness in Hadoop, and why is it important? Answer: rack awareness is a feature in Hadoop that helps the system optimize data placement based on the physical location of nodes, i.e., which rack they belong to in a data center. Hadoop ensures that replicas of data blocks are stored on different racks to improve fault tolerance and minimize data loss if an entire rack fails. It also optimizes network traffic by reading data from nodes on the same rack when possible. 30. What are input splits in Hadoop? Answer: an input split in Hadoop represents the logical unit of data that a mapper processes. It defines the portion of the data that a single mapper will work on. Input splits are created based on the block size in HDFS, but they do not contain the actual data. Instead, They refer to the locations of data blocks in HDFS that need to be processed. 31. How does Hadoop handle load balancing in HDFS? Answer. Hadoop handles load balancing by distributing data blocks across different data nodes in the cluster. The name node monitors the available storage and ensures that blocks are stored on different nodes, balancing the load across the cluster. Additionally, the Hadoop Balancer tool can be used to manually balance the cluster if some nodes become overloaded or underutilized. 32. What is the difference between block and input split in Hadoop? Answer. Block, a physical unit of storage in HDFS. Each file is divided into fixed-size blocks, e.g., 128 megabytes, which are stored across multiple nodes. Input split, a logical unit of data for processing in MapReduce. It refers to a portion of the input data that will be processed by a single mapper. Input splits may correspond to blocks, but are not restricted by block boundaries. 33. What is a sequence file in Hadoop, and why is it used? Answer. A sequence file is a flat file format in Hadoop used to store binary key-value pairs. It is used to support large datasets where data needs to be processed in sequence, and is commonly used as an intermediate format in MapReduce jobs. Sequence files are more efficient for certain use cases than regular text files, as they allow faster data retrieval and storage. 34. What is the use of the distributed cache in Hadoop? Answer. The distributed cache is a mechanism in Hadoop that allows applications to cache files, such as large text files, jar files, etc., locally on each data node before the job starts. This cache data can then be accessed during the execution of the MapReduce tasks without repeatedly fetching it from HDFS, reducing network traffic and improving performance. 35. How does Hadoop handle security, and what are some of the security challenges? Answer. Hadoop provides security through Kerberos authentication, ensures that only trusted users and services can access the Hadoop cluster. Service level authorization limits which services can interact with one another. However, challenges remain with securing data at rest, implementing fine-grained access control, and integrating Hadoop security with other enterprise systems. 36. What is the difference between HDFS and other distributed file systems like Amazon S3? Answer. HDFS, designed specifically for batch processing with high throughput and fault tolerance through replication. It's tightly integrated with Hadoop's ecosystem. Amazon S3, a cloud-based object storage service. While S3 is not natively designed for big data processing, it is widely used in Hadoop environments for its scalability, durability, and easy accessibility over HTTP, though it lacks the same level of performance tuning as HDFS for large-scale batch processing. 37. What are some common performance tuning techniques for Hadoop? Answer. Increasing the block size, reduces the number of blocks, and increases the throughput. Adjusting the number of mappers and reducers, properly setting these values based on the data size improves parallel processing. Combiner functions, reduces the amount of data transferred between map and reduce phases. Speculative execution, helps minimize the impact of slow-running tasks. 38. What is the purpose of the Hadoop Balancer? Answer. The Hadoop Balancer is a tool used to rebalance the data across the data nodes in an HDFS cluster. When some nodes are underutilized or overutilized, the balancer redistributes data blocks to ensure that storage is evenly balanced, which helps maintain performance and fault tolerance in the cluster. 39. What are some key differences between Apache Hadoop and Apache Spark? Answer. Hadoop MapReduce processes data in batch mode, where jobs are split into map and reduce tasks. Apache Spark offers both batch and real-time processing with an in-memory computing model, making it faster than Hadoop for certain use cases. Spark also provides richer APIs for data processing, such as Spark SQL, streaming, and mlib. 40. What is the role of Apache Hive in the Hadoop ecosystem? Answer. Apache Hive is a data warehousing solution built on top of Hadoop that allows users to perform SQL-like queries on large datasets stored in HDFS. Hive translates these SQL queries into MapReduce jobs, making it easier for non-programmers to interact with Hadoop and analyze big data. 41. What is a partitioner in Hadoop, and how does it work? Answer. A partitioner in Hadoop controls the division of the intermediate key value pairs produced by the mapper into reducers. By default, Hadoop uses a hash-based partitioner to distribute the keys evenly across reducers. However, custom partitioners can be written to control how data is divided between reducers, improving job performance for specific use cases. 42. What is HBase, and how does it relate to Hadoop? Answer. HBase is a distributed, column-oriented database that runs on top of HDFS. It is used for real-time read/write access to large datasets. HBase is designed to handle structured data and provides capabilities for random read/write operations, making it complementary to Hadoop's batch processing. 43. How does Hadoop support compression, and what are the benefits? Answer. Hadoop supports various compression codecs like gzip, bzip2, LZO, and Snappy. Compression reduces the size of the data being stored and transferred, resulting in lower storage costs and faster data transfer between nodes. It also helps in reducing the I/O overhead during MapReduce operations. 44. What is the role of Apache Pig in Hadoop? Answer. Apache Pig is a high-level scripting language for processing and analyzing large datasets in Hadoop. Pig scripts are translated into MapReduce jobs, simplifying the data transformation process. It is particularly useful for tasks like data cleaning, ETL, extract, transform, load, and complex data pipelines. 45. What is a job tracker, and what happened to it in YARN? Answer. The job tracker was the central service in Hadoop 1.x responsible for resource management and job scheduling. In YARN, Hadoop 2.x, the job tracker was replaced by the resource manager and application master, which improved scalability and fault tolerance by decoupling resource management from application management. 46. What are Avro files, and how are they used in Hadoop? Answer. Avro is a row-oriented data serialization system used in Hadoop for efficient data exchange between programs. It supports schema evolution, allowing users to read data written in an older schema using a newer version of the schema. Avro is used in Hadoop for both data storage and RPC, remote procedure call, due to its compact binary format and schema support. 47. What are some key Hadoop metrics to monitor? Answer. HDFS capacity, the total and available storage space in the cluster. Node health, tracks if nodes are up, responsive, and not overloaded. Job completion time, measures the efficiency of MapReduce tasks. Data skew, uneven distribution of data can affect performance. Monitoring these metrics helps in ensuring the smooth functioning of the cluster. 48. How does Hadoop handle fault tolerance? Answer. Hadoop achieves fault tolerance through data replication in HDFS. Each data block is replicated across multiple nodes so that if one node fails, the data can still be accessed from other nodes. In the case of a task failure during MapReduce, Hadoop automatically re-executes the task on a different node. 49. What is the purpose of checkpointing in Hadoop, and how does it work? Answer. Checkpointing in Hadoop is a critical process used to ensure fault tolerance and system recovery. The purpose of checkpointing is to periodically save the metadata, such as the namespace, edits log, etc., from the name node to a stable storage location. In large clusters, the name node accumulates edits log files over time, which store all changes made to the file system. If these logs become too large, recovery from failures can take a long time, making the system vulnerable. The secondary name node, or a checkpoint node, performs the checkpointing process. It merges the edits log with the latest image of the file system metadata, FS image, thus creating a new, updated FS image file. This reduces the size of the edits log and helps in faster recovery during name node restarts. The secondary name node does not act as a failover for the name node, but assists in maintaining system reliability by performing this periodic merging and saving of the metadata. 50. What is the use of Apache Flume in the Hadoop ecosystem? Answer. Apache Flume is a distributed system used to collect, aggregate, and transfer large amounts of log data into Hadoop. It is designed to efficiently move data from various sources to HDFS or HBase for further analysis, making it an essential component for streaming log data into Hadoop clusters. Thank you for watching. Like, share, and subscribe. Visit parthakachana.com for technology resources and stock analysis.